Okay guys, now let's define PIFA antenna using FICO software. For this, I just need to define the variables first. First, let's define L1, that is 20 millimeters. I'm adding it. Now L2 is just 50 millimeter. Add it. L3 is again 20 millimeters. Now just I'm defining the width, that is W is 5 millimeters, and now I'm just defining the gap. Gap is just nothing but 2 millimeters. Now I'm defining the ground, that is ground plane for that XX box is 0.2 and for YY box is 0.1. Just after defining all the parameters, I'm just creating this, and now I'm just gonna add a rectangle with base center. The width should be the ground as XX box and the depth should be the YY box. I'm just creating the ground. Yes, I have created a ground. After that, I'm just adding the another rectangle with base center and just customizing the work plane. I'm just start from the origin as Z from gap, and the U vector should be from Y plane as 1 and V vector should be from Z plane is 1 to change the orientation of my rectangle. So now I'm just assigning the values to my second rectangle, that is for V length, it's V is along the depth side, so 0.5 into L minus 1 gap, and depth is L1 minus gap. After checking all those things, I'm just creating this. Now let's add another rectangle. I just custom the work plane as I'm starting the origin from X is equals L3, and from the geometry I just made corrections on the U part, that is minus L1 by 2, and with this L1 and depth is W. I'm just defining, and with base center just modifying the work plane, that is to make us the same orientation of the previous rectangle. The only thing is U is Z is equals minus 1, and after setting all those things, I'm just creating the second rectangle. The last part is the last rectangle that should be over the thing, the two rectangles. So just I'm customizing the work plane according to this. The L explain always starts from the origin, that's L3, and I'm assigning the values to base minus L2 over 2 with this L2, and depth is W, and N should be L1 so that it should come over all the previous two rectangles. Yes, we done it, and I just created all three rectangles and I have merged it. Now the simple part is I'm just gonna add a line. For that, the end part should be U is 0.001 and V is 0, N is gap, and just I'm creating, oops, I just made a mistake, U is 0. Yes, I have created. Yes, now just click the wire, and I'm gonna use a port, so I just create a wire port, and the wire should start, yes, the location should start from the starting point itself. So I'm just merging all these rectangles and line, that is union, right? So I'm just unioning it. Yes, everything I have created. Now just add the frequency range, linearly spaced, and starting frequency is 1 gigahertz to 2 gigahertz. The number of frequency I am setting is 51, and after that I'm just creating the mesh. So it's just automatic mesh. I'm just modifying the wire segment radius, that is 0.5 millimeter. After defining the mesh, yes, I'm just rechecking whether my antenna is completely done or not. Yes, in all the perspectives I'm checking, yeah, it's completely right, and I just moving to the isometric view. Okay guys, we have done our PIFA antenna using the FICO software. Just I'm saving my document. Yeah, yes, okay, let's solve this. Oops, everything is done now, but unfortunately I just forgot to request the current and far field. So just where's the current? Yeah, I just made the current. Yes, just create the current, and after that just create the 3D pattern of far field. Yes, I just created. Yes, I'm checking. Okay, yeah, perfect, everything is right. Okay, before solving I just need to hide the far field because it should not uh, collaborate with anything. Okay, fine. Yes, I'm saving these corrections and just I'm running it. Yes. Okay, after running I'm just giving post FICO to see my output. Okay, now just I got my output screen. For that I'm going to Cartesian plane and I'm giving the far field. Yes, everything in, I'm just enabling the decibels, it's in frequency, right? Another Cartesian plane to see the gain, that is of frequency of reflection coefficient. I'm just giving reflection coefficient and VSWR, everything we can add in the same graph itself. So that for that again I'm adding the voltage source in this graph itself, just adding reflection coefficient. Yes, both is in reflection coefficient as well as VSWR in the same graph. Yes, now let's see the radiation pattern for that polar and far field. Just give the theta wrapped. Yes, set the frequency as 1.5 or 1.5 because we just assigned the 1 gigahertz to 2 gigahertz, right? So now let's label the decibels. Now in 3D plane we can see the far field and the current of the antenna design which we have designed. This PIFA antenna's far field here. Yes, now just I'm adjusting. Okay, fine. Now this is the current plane. Yes, we can animate it. Yeah, right. That's it, guys. This is all about our PIFA antenna using FICO software.